Hey guys, how's it going? Welcome to the stream. So a couple nights ago was pretty cool. We got some cool stuff working. I think I forgot to mention actually that last stream, which was Monday, was my 50th stream, which is pretty crazy. So tonight is 51. Hey, what's up, Liz Gamer? I'm pretty good, you? So yeah, 51 streams tonight. It's pretty crazy. Can't believe it. It's a lot of streams. It's been really cool. So yeah, last stream was awesome. We finally I kind of like finalized the code for No, anyone spends too much time selling everyone on Lisp. Well, no, Lisp is very cool. I actually, I've done a little Lisp. I've done some Scheme. Gotten through most of the little schemer. And I do enjoy, functional programming. I wanted to take a look at Clojure, actually. Oh, thanks. Thanks for watching my videos. Appreciate that. Oh, thanks, man. That's really cool. So yeah, so last stream, we got some stuff checked in. Yeah, I got the whole like networking of two instances, like where one is using my CPU implementation and the other instance is using another CPU implementation, the Vectrex one. And we basically hash all the instructions per frame, and we send the hash from one to the other and compare. And as long as they're the same, we're good to go. And if not, well, we stop. And using this system, we were able to fix a couple of CPU bugs. We fixed increment not setting overflow correctly. We fixed the rotate left not computing overflow and negative flags. We fixed rotate right so that wasn't storing its result at all. At the end of last stream, we actually started looking at trying to like kind of nail down I think a 50 hertz frame rate. And yet I kind of abandoned this. I looked at it a little bit after the stream because, you know, I was just curious to see. Oh, thanks for the follow, man. Supposed to have follow notifications or something on here. Maybe it'll appear at some point. So, yeah, Streamlabs is supposed to like show when people follow me. Anyway, I saw the email pass. So thanks for that, Lisp Gamer. Yeah, so yeah, we were looking at this timing stuff, and in the end I abandoned it because actually I just tried introducing like, you know, some small sleeps every frame to see if it would have any effect on my CPU usage, and it had really no effect. So my game, the instance when it runs, it uses about 20% CPU on my machine, and no amount of sleeping. Oh, there we go. Guess it's just a little bit delayed. Yeah, so no amount of sleeping seems to bring that down, and I mean it's not a big deal. I'll profile my emulator at some point and understand where the bottlenecks are a bit more. But yeah, right now it's perfectly fine the way it is. So I'd like to continue looking for CPU bugs and stomping those out. So I have a. Just give me a second. Just doing something off screen here. VS Code. Okay. Yeah, so I think I had a. Where is it? Code active. Vectrexy. And it's called compat. That's it, my compatibility list here. All right. So yeah, so I have this big. Thanks for the follow, Cypress. Appreciate it. And my follow count is starting to get close to 100. It's pretty awesome. Really appreciate it, guys. I think I'm at 91, 92 or something now. It's pretty cool. So, yeah, so I have a whole bunch of games here that last time I tested them, so I have kind of like a split here. Between commercial release ROMs, unreleased ROMs, and homebrew ROMs. So I want to like tackle getting at least the commercial ROMs working first, and then we can take a look at the other ones. Hey, Blame Classic C, how's it going, man? So yeah, and last stream, what we checked just before the end of the stream, we actually tried running Spinball, which originally had an invalid read, and what I write here, zooms in too much, invalid reads from unmapped and card to Vectrex CPU works. So this is where I knew that the Vectrex CPU worked, but mine didn't, and so there had to be a difference. And it turns out it's definitely one of the couple of things I fixed, most likely the rotate left. We had it zooming in too much, and now it actually works fine. So I can show you that. Make sure this is built. Yeah, we're good. So if I go to, where did I put it? Spinball here. Yeah, let's maximize it. Maybe I won't maximize it. I seem to have some... Okay, so we are still actually getting invalid reads. That's interesting. Do I get those invalid reads when I use the Vectrex CPU? I'm not sure. I should try. Because see, now my frame rate's getting hit by the fact that we're spamming the output this way. So if I run, so this is the other one here. So if I run Spinball from this side, okay, remove client, and let's see if this guy gives me the same. The shader looks nice. Thanks, Cypress. Appreciate it. Yeah, I had a lot of fun writing the shaders for this emulator. Trying to simulate the kind of the decay of a CRT, and I have some like glow effects and stuff. Yeah, let me just set the defaults here. Like, let's say 20/20 or something. Or maybe 50/50, I don't know, something like that. Okay, yeah, so you see when I use the Vectrex CPU, I don't get any of that that output. That's interesting, right? So it looks like there's still a difference. So what we'll do is we'll do the client server thing and see if we can find any other another difference there. But yeah, for the shader thing, I just wanted to say like, oh, this thing didn't work. I don't know why. Oh, I know why actually. Yeah, it's because I need to put negative. I think it's so annoying. Properties. Where are we at now? Let's say minus 1831 124. Let's do that. Okay, there we go. Now it should open there. Whoops. Okay, yeah, so for shader stuff, I've kind of shown this before, but since you're mentioning it, so I have like all this stuff here. Like I can disable the blur effect. And then I have a whole bunch of stuff here to like mess around with the blur, like how thick it's gonna be, and the glow radius here also has some effect on that, giving wildly different feels to the glow. And I also have, if I disable blur, I have this is like the darken speed scale. So this basically controls how quickly we darken the lines. So all of these things come into play with the shaders. I have no overlay on this one, but this actually controls the alpha of the overlay. So yeah. All right, so let's see if we can catch another problem, but this time specifically when running Spinball. So I had a path for Spinball here. So we'll run the server on Spinball, and then we'll run the client on Spinball and see what we get. It's not accepting input, or come on. I think having RGB values for the vector colors would be nice. Yeah, actually I saw someone did that on a real Vectrex. They actually modified their Vectrex to produce colors based on, I forget what there, but it was pretty cool. Okay, so here we got an instruction hash mismatch in the last 39,027 instructions. And here, same thing. I was actually thinking, because I keep having to do this, where I have to type the trace and all that, and I was like, you know what I should just do is make the mismatch output. Like when we hit a mismatch, just go ahead and do the trace. Why don't I do that, actually? So we don't have to keep doing this. Although, how am I going to name the trace? Ah, okay, you know what? Never mind. So you're saying like, oh, okay, do you mean like just have like a base RGB value rather than white, just control the color, the base color? Is that what you meant? I mean, I could do that. That would be pretty trivial. All right, so let's say we trace this many instructions, and this will go to, this is the server. Just call it my CPU.txt. Just gonna delete these old ones here. So there's my CPU, and similarly, we'll do the same thing here. All right, so we got our traces. Let's diff them. Okay. So the first diff is on this load A instruction. So we want to load into A. We're trying to dereference at this absolute address here. So let's see what's happening here. Huh. Very surprising. See, what's surprising is that here the instruction is load into A, and then this is an indexed mode instruction, if I'm not mistaken, where we want to read the address at 1516, at least that's how I understand it, right? And then take that address and then dereference it again. And so if that's true, what do we got here? These are the accesses that we are making. So there's the 1516 where we read. So yeah, so it actually we'd have to read 2 bytes to get the address. So 1516 and 1517. So that returned 80 and FA, and then 80 FA returns 0 here. Now what is this here? 10 E9 returning FE. So that's done. Okay, well, I'm not quite sure why we're reading at 10E9. That might, oh, that must be because this kind of instruction, we need to read 1 more byte. That's it. This is that weird one where we have 10E7 and 10E8 for the instruction here, but we also have to read then the next byte at 10E9 to know like the mode. Yeah, let me just refresh my memory here. This is one of those complex index mode operations. So what we're talking about here, yeah, it's this one. See, read indexed effective address. What we must be doing is, okay, let me see, A6D8. Okay, so that's it. You see how we do this read post byte. So that's the first read that we're talking about here, and we get the post byte back, which is FE, and then we take a look at the post byte, like we look at a whole bunch of bits in the post byte to understand what it is we're supposed to do. Okay, so that takes care of this read. So FE is the same in both. What's weird is how, you know, we're reading 1516, which is what I would expect to read, but from Vectrex it's actually reading at 1416 and 1417. That's really surprising. Really surprising. A6D8. A6. So there's our load A. So that is the indexed mode version. Sure. Okay, so that's the A6. Now the D8. Do an upload here. So we say read operand value 16. Look up CPU ops. We're going to get the address mode. It's going to be indexed, right? We're going to get indexed, yeah. And we're going to say read operand value. I mean, in our case, we want to do a read operand value 16, right? Is that the one we're going to end up with? Let me just double check here. Well, actually, no, it's an 8, right? Sorry, because it's loaded into A. So no, it is going to be the 8-bit version. So we come into here, we say read operand value 8 for indexed mode. So sorry, I just got to refresh my mind a bit here. It's been a long time I haven't looked at this. Okay, so for all except for immediate mode, we do this read EA16. To get back the effective address, and then we read again from there. And so I guess what it boils down to is when I compute. Oh yeah, look at that. 1418 plus 254. Just check something here. 1418 plus 254. 1660. So that's not at all what I was expecting. You know what I need to do is I kind of need to debug this. So the post byte, which is D8 here, yeah, this is what we're gonna do. We're gonna debug this. Let's do that. Where are my consoles? Here somewhere. Quit. Okay. Okay, so it's at 10E7, so this instruction at 10E7, let's go into debug actually, so we get all our symbols. So this is interesting, right? So this is like an indexed mode bug, most likely, which is not too surprising because index mode is quite complicated. It's the most complex addressing mode for the Vectrex CPU, the 6809. So it's possible I have a bug in there, and if I do, then that would explain probably like why a bunch of games don't do the right thing. And I have a lot of games, like I have a lot of in my compatibility list of like invalid cartridge read, right? And this is the kind of thing that looks like I've got something wrong with you know, something like an indexed mode read or something. So hopefully if I fix this, I could fix a bunch of these games. We're looking at Spinball. Okay, so let's launch Spinball like this. Let's break into the debugger. And let's set a breakpoint right on this address here. Hopefully it won't take too long to get there. We're going to stop right at this instruction, and then we're going to step into the debugger to see what's going on. If this takes too long with debugger, I can go back to release mode and just disable optimizations on certain functions. Yeah, this looks like it's taking a long time. Okay, never mind. Let's do this another way. So we'll go into release with debug info. What we will do is, we know we're going to be debugging index mode, so I have a forget what I called it. I have some macro to disable here. Optimize off. So let's do that on our friend read index here. So optimize off here. Back on here. And I also want to do it on the execute instruction. Okay. Okay, so that's better. Now let's break here. Let's set that breakpoint again. What was it on? 10E7. Okay, so here's our breakpoint. So we're about to execute this instruction. So let's set a break somewhere at the top here, so like we can step and see. So I'm gonna step. Okay, and here we are. Not getting much in terms of debug symbols. Okay, there's cycles. Alright, here we go. CPU op page is that. The CPU op is load A index mode. So that's what we expect. I can't see opcode byte, unfortunately. All right. So there's our load A. We're gonna go into read index here. So here's what the read we're going to make for the post byte. Why can't I see the... That's post byte. That sucks. Okay, well, let's just step a little bit and see where we go. Okay, and then we read post byte 2. So this is a plus or minus 7-bit offset. Right. Okay. So 254 is supposed to be a signed value. I'm not showing it that way, but if it's a 7-bit offset.
I set my sail, fly the wind, it will take me back to my home.
Was I actually outputting this as a... Can't see anything. Let me see, in my disassembly, what did I do here? Disassemble indexed instruction. Let me just see what I did for this case. It's this one here, right? No? 0B1000. Here. I did the register select, the post byte, computed an offset, and then I did here. Okay, so I am showing the offset just as a... I don't know why I didn't show. Okay, so I just wanted to show it as an integer offset. That's really weird. Okay. So it is decimal 254. Which should have been -2. See, that makes more sense. Because then it would be 418 minus 2 bytes. And what am I doing? Am I doing 418. Have a look at my code here. See, I am computing it as a signed version of the value. I'm gonna just gonna rebuild because I really want to see my debug symbols here. Want to see if we can get some. Still not getting the opcode byte, so that's not a good sign here. Try reopening Visual Studio. I've had issues before where I need to reload everything for it to actually work. Yeah, not looking good. Basically, what's really happening here is this optimize off is not doing its job. Strangely. I think if I just disable optimizations, it'll go back to crap speeds, but I just want to give it a shot. I don't know why this is happening. I've been able to debug release with debug symbols by disabling optimizations on functions. For some reason, it's not working right now. It's really odd. Yeah. Funny, I feel like I've had this problem before with the not handling the sign of this offset properly, but 15, 16. It's just weird. 14, 18 plus. Okay, so I can see that the offset is 256 from what I would have wanted. Still not getting the... That's alright. Okay, so we're here again. Let's see if I can figure it out. Push D-word pointer post byte. Okay, so we call register select. Move CL byte pointer EDI plus 9. So there's the 254. So we did read 254. And now we're going to ostensibly sign extend it. But it's an unsigned char. So maybe that's the thing. The fact is that it's an unsigned int right now. And so then this won't get sign extended the way I think when we put it into offset. Move ZX EDX CL. So let's see. EDX. Yeah. I would have wanted this to be -2. Yeah. Right. And then of course that's not going to work. So this is not doing what I expected. But what I would have wanted here is, so let's say, I think what's happening is basically we have a, let's say unsigned char 254. And we take that and we're trying to cast it to a signed, I'll say short for in this case, and then we get exactly the same bit pattern. But in fact, if I took this and this were a signed char to begin with, then it would get sign extended. You see? All the ones here, and then we'd get the -2. So there's the issue. There's the bug. So to fix it, all I need to do, since yeah, now it makes me wonder about all of these other ones here. But anyway, let's start with this one. Oh no, here it's okay because we combine them, so this should be okay. So yeah, in this case, what we want is our post byte. We need to first cast it to a signed uint. Right. Okay, so maybe I could fix my S16 here. How many times do I use this anyway? Yeah, so all of these cases must not be doing what I expect. Basically, my S16 function here, we want it to cast, but we want it to actually first cast this guy. But I don't even know what T is, really. We wanted like the signed version to begin with. Is there like a type trait I can use that gives me the signed version for a T? Sign modifications. Make signed. Let's see. There we go. That is part of type traits. Okay, so let's see if this does what I want. So what we're doing is we're saying if T is an unsigned, if I can actually get it to compile. Let's see here. Cannot convert from uint T to std make signed of T with T equals to uint 8T. Unsigned became int, const unsigned became const int. Why? What's the problem here? Oh, okay. It's just because I need to grab the type. Oh, okay, and I see. And we need to cast to that type. So first we take V and we make sure to cast it to the signed version of whatever type V is. So if it's in our case, let's say it's an unsigned car, an unsigned uint 8T, it'll become an int 8T first, and then it'll get cast to an int 16. So this will do the sign extension. So this is actually used in a bunch of places, so I wonder if this will fix issues. Because S16 here, well, actually it's only used exactly in this code here, so it's not actually used very much, but I guess maybe all of these cases hopefully would get fixed by this. Because I think in all these cases I'm dealing with uint 8Ts. So here's a plus or minus 7-bit offset actually, yeah. And here, I suppose we're expecting D to be sign extended as well. Plus or minus B. I need to take a look at these. But yeah, I think that's the case. It's always going to be a seen as a signed value for this to work. All right, so let's see. We'll put that same breakpoint we had. Copy. Well, technically I don't really need it because that breakpoint only got hit once for that instruction, but anyway. All right, so step it. Go back to disassembly. See, this is now a move SX. This is a signed extension. Move with sign extend. So now we're gonna actually get, we should get what we expect. Now CL has 254, and okay, now it's not using EDX, it's using CX this time. And yeah, so it worked, but it's this right now it's showing this as a signed, unsigned short. But if it were to show this as a signed short, we should have -2. Okay, so let's say we just disable this and we disable our breakpoint. See, now it's working and we're not getting any more of that spammage for invalid reads. So we may have actually fixed this bug. It's very cool. So the way to be sure now is we're going to run against the Vectrex and compare the instructions again. So let's see. I swear, I'm sure there's a stream, you know, a while ago where I actually dealt with this exact kind of problem. But I think I dealt with it perhaps in the debugger, on the debugger side. Wait a minute. Did I actually fix anything here? Oh, okay. That's funny. You know what? Yeah, okay, so I just fixed the debugger's output, but I didn't fix the actual problem. Or did I? No, I did. I did, because S16 is used here. Yeah, no, so let's fix on both sides. I guess because I was debugging it in the debugger's disassembly, which does the same thing. So we saw it get fixed here, it should be fixed here as well. Okay. So let's run the two again. Get my server up. So that's the server for Spinball and the client. So far so good. No desyncs yet. So let's try and play. Frame rate's a bit slow, but it's okay. Still playable. Oh, we got an instruction hash mismatch when we launch the ball. Cool. So let's see what this one is. Okay, so we'll look at the diff. Okay, so this time it's at this push to the S stack, the system stack. We're trying to push the control codes. Is that what it's called? The condition code register, the status register, and at this point for us, when we read CBDC, we have 58, and here now we are storing 58. So that means that what's in our condition code is different. Yeah. That's okay. So yeah, I didn't think about this. Yeah, this is almost certainly the fact that Vectrex and my CPU, we don't set the half carry in the same way. Yeah, like, see, pretty sure that that's the problem right now. So the value that we have is, I have 58 and the other one is 78. So let me see here, 78. So that's it. So the first byte is 0111 for the other one, and so the difference is basically this bit right here, and that bit corresponds to EFH. Yeah, so it corresponds to the half carry. So this is not really a real bug. I don't know how to get rid of this. So I have a hack in my debugger side where when I'm tracing, not to hit this problem, I like force both sides to set the half carry on the debugger side, so for the trace info to be the same, but of course that doesn't actually change the flags, and so I forgot that we have an instruction that could push the condition codes, and for sure that's going to end up looking different. That's fascinating. I'm trying to think, like, how do I get rid of this problem? I mean, other than trying to make my instructions set the half carry exactly in the same way as Vectrex. And again, this is setting the half carry to true or false for instructions for which setting it is undefined. Okay, so as an example, see here, this is the hack I made where I just said, okay, let's just set the half carry to false in terms of the trace info. Let's say we remove this hack, right? Let me quit these. I'll just re-explain the problem and see if we can come up with a solution. And maybe the solution is going to have to be, to get this working. I have a few ideas there. Obviously, one of them is just go ahead and try to do the same thing as Vectrex for all those cases. But maybe we can be a bit smarter, a bit more clever. So let's see. So we built this. Technically, I think I do need to build this. Got to build both sides, the server and the client, the two versions that I'm running. So let's see if I run the server now and I run the client. Now we should get a desync fairly early on. See, we already got one. In this case, 42,016. Okay, so let's take a look. See, that's lots and lots and lots of blue there. So that basically corresponds to, for instance, here. After this compare A instruction, I don't set the half carry, whereas half carry got set to true. Now, if we go take a look at compare A and how it's supposed to work, here we go. So compare A, compare B. It says half carry undefined, right? So for me, that just means do nothing with it. So I go to op, compare. Okay, yeah, I just end up using subtract impl here. But anyway, subtract impl sets carry. See, I don't even touch the half carry at all in my subtract impl because it's not necessary, right? I actually call add impl, and then add impl goes and sets carry, overflow, 0 and negative. And nowhere in here do I ever touch the half carry flag because it's undefined. You're not supposed to, you know, it might be set, it might not be set. So I wonder how many other instructions there are like this. Like, I mean, we could say, all right, fine, you know, for compare, specifically for compare. If we did this here, just to kind of emulate what what Vectrex does. So let's build this. I'm gonna have to quit the other two here. Quit these two. Lisp Gamer says set it at random. Well, so the thing is, I need to, like, I'm comparing my CPU implementation against the Vectrex one, right? So I need to, if I don't match what Vectrex does, then I get this difference that gets called out, you know? And I thought I'd gotten away with it by, you know, being clever in my debugger, and when I build my trace info by just slamming the half carry to false in terms of the trace info, not in the actual CPU. But I forgot that if there's an instruction that actually, say, pushes the CC, all of a sudden the value in the half carry ends up looking like a difference, which is exactly what's happening here for me, right? I don't know if that made sense. Did that make any sense? I could try to re-explain it. Because basically we have these two CPUs and they're executing. And say that they both now execute the compare. One of them will set the half carry to true, and mine just doesn't set it at all. So it remains whatever value that it had before. You know, which for me, saying it's undefined just means leave it alone, right? I know it doesn't necessarily mean that, but anyway. And then what happens is that, so the two CPUs have now, we in their state, the half carry is different. But I'm actually not comparing the values of the CPU. I'm creating a trace information structure. And in that trace, then I take that trace information structure, I hash it into a value, and then I send that from one to the other and compare. So in that struct, the trace struct, I went and said, screw it, let's just always set half carry, like let's ignore half carry. So let's always set it to the same so we don't get these differences. But that was working fine until we hit an instruction that actually pushes the control codes to the stack. And in that case, what I'm hashing also are all the reads and writes to memory. And in there we get a write of the CC values into memory, and that's where we got our difference before. So I mean, the only way to get, really one way to get around this is to just say like, oh, we better like make my CPU do the same thing as the other one in terms of half carry. So that'll work. Or I'd have to put like special case logic in my debugger to say, oh, are we in the process of, did we just execute a compare? If we did, right, then, you know, no, sorry, not a compare. Did we just execute a push? And if we did, and it's a push specifically of the control codes, like let's do something there as well. Or like let's not hash the write to memory. I don't know. It's a way more hacky solution, I suppose, and complicated to get working. Maybe in the end, the path of least resistance here is to just set half carry when it's undefined. Like I wonder how many of these there are. Can I search for this in here? So far it looks like there's only 7, 3 of 7. So there's left shift left. So that's probably another case where it's done differently for me and Vectrex. Negate, subtract with carry doesn't do anything with it. So maybe if I go through to these 7 cases and just set it to true, we'll pretty much match Vectrex. Okay, so we got actually a mismatch again here. So let's see. So yeah, just to say it again, we got to compare A now. Let's see if we shouldn't have compare A anymore. Compare B. Did I really not handle the all compares? Oh, that's just hilarious. So now what happened is that for compare B, Vectrex set the half carry to false. So what this is telling me is they may do the wrong thing somewhere, but no one cares. Yeah. What I'm guessing here is that the value is undefined, but like in Vectrex, he's probably, whoever wrote this emulator, I don't even know who it is, but went ahead and like is computing the half carry, even when it's not necessary. You know, so that's probably what's happening here. Like I'm setting it to true arbitrarily, but that's not really what is happening on the other end. So like so I guess if I did a calc half carry, I have here a calc half carry from add. See, I even had this add impl where we tell it whether to update the half carry or not. So what if I just always did it? Maybe then we would be more closely matching. Let's try this. And we'll undo the change I made prior to this. What is wrong here? Oh yeah, we can't do it for 16-bit. Yeah, that makes sense. So let's say we do it for the 8-bit version, and we go back and we undo the... Okay, we undo this. Yeah, I'm starting to get the feeling, because see, subtract impl will call add impl, and add impl, under certain conditions, says whether to update the half carry. But what if we always did it? You're asking what mic I'm using? Is that because it's not picking up sound well, or? Because I'm using a, what's it called? The blue ice thing? The ball? You can kind of see it here. on the keyboard camera. Yeah, let me know if you can't hear me well or something. Control-Shift B. It's doing a good job. Oh, thanks. Thanks. I'm glad to hear that, actually. Yeah, I find like the mic is it's important to invest in a decent mic, because when I started streaming, I was just using the mic on my camera, you know, like on my web camera, and when I would listen to my audio to my stream later on, I found it sounded terrible. So I started looking into what do other people do, and yeah, I spent a little bit of money and bought myself a proper mic. I have better balance on my music. It was a little loud, too loud to start. So actually I didn't change the music volume, but I think some of the tracks that play through OC Remix are louder and some are, like, it's not completely normalized. But if you do find it too loud at some point, let me know. I could reduce a little bit the audio capture, like this for instance. Okay, so I just built this one. I wonder if I should put like a normalization filter for the audio output for the music. I could try that at some point, but you know, then it'll maybe warp the music. Okay, so these are built. So let's just try this again. Already got an instruction mismatch. That sucks. 35, 305. Okay, so that's interesting. I think the compare has been taken care of, but yeah, you see left shift left. We saw that in the document, right? How now I've got my half carry was not changed, and yet his got set to false. Really weird. So we have our arithmetic shift left, which I think compare. There's left shift left. So I really wonder, you know, is he always setting it to false, or is he just computing it in the left shift left case? Maybe Vectrex just says if it's undefined, I'll compute it anyway, which is a bit strange. Oh, you want to know what the name of the mic is? Let me see if I can find it, because I don't. It's a blue. Oh, could it be the Blue Yeti? I think that's what it's called, but mine's like a. Oh no, it's not that one. It's an ice. Yeah, it's this one. The Snowball ice something. But now there are two versions of it. There's like one there's a cheaper version and there's the more expensive version. I'm trying to remember which one it is that I bought. Kind of looks like this one. It's a little funny looking, but I kind of like it. I'm wondering if there's like a snowball and a snowball ice. I think that's the difference. Blue snowball review and snowball ice. Okay, so this is the company. This is their website. Let's see here. Snowball. Classic studio quality USB microphone. Okay, so there you go. So here's the difference. You've got the snowball and you've got the snowball ice, which actually looks like it's cheaper. Yeah, so mine is not this one. I don't have this stand. There's also studio. I don't think mine is studio though. I think mine is this one here. The black version. Yeah. This one looks like mine. So yeah, if you're looking for a decent mic, this company makes some nice mics and they're affordable. I think the snowball is in a pretty decent price range. And I got mine on sale actually when I bought it. So you know, if you wait for sales, you can usually get one on sale. All right, so left shift left. Like if I did this, like what do I set it to? It's just obnoxious. You know what? I think I'm gonna cheat a little bit, even though I've managed not to look. I think I'm gonna go take a look because I don't know what it must be doing for arithmetic shift left. Oh, that's interesting. Because it implements it as data plus data. So we do see that it's setting the half carry, and it's doing it because it's interpreting it as an addition of the values. I was just thinking, the other way I could go about this is modifying this CPU to not compute this guy. Oh, hey, Rule Jonathan. Second time here. That's cool. So what am I doing today? So I'm continuing to fix bugs in my CPU implementation. Doing that by comparing runs of my emulator with my CPU and another one that I know works from another emulator. So fixed a few bugs already with that. Right, because so shifting left by 1 basically means multiplying by 2. And it's interesting how in this emulator it says, okay, well, we're just multiplying by 2, so we're just adding by itself. And so if it's implemented as an add, it should do all the right things. So it's making me wonder, actually, if I were to, instead of doing it this way, if I was to call my add implementation, let me just take a look. And it's probably done that way in the hardware. That's what I'm thinking. Trying to think, what am I doing here with the carry? Subtract impl. Right, we pass in the carry, okay. I guess I just passed 0 here. So, okay, so we would compute the addition here. We would compute a half carry from those two. Carry is, what am I doing here? Test bits. Yeah, I've got like a more specific test going on for carry because I know carrying means bit 7 was set in the original value. But here I check for carry by looking at the 16, yeah, so by looking at the 16-bit value, I just look to see if any bits were set in the top. So that would do the same thing. Overflow, yeah, again, a more specific overflow. Overflow sign changes. Here I'm looking for overflow when we add. So yeah, I mean, I think I could do this as an addition. Let's see. It'd be something like value 0 for carry, pass in the condition code, and what is this? CPU impl update half carry. Now, what am I doing with the value? I have to store it back into value, right? Like this. Let's see. Let's see if this works. Okay, so I got a mismatch. Let's see. So let's see if we're going to get at the same place. So we had gone in for the left shift left B. No, so we got at a different place. I think the left shift left B ended up working out. Yeah, here it is. Yeah, so now my half carry looks like it's being set in the same way. Yeah, see, it went from capital to small in this case because we're doing the same as Vectrex. Oh, look, if you don't understand, you know, maybe it's my fault. I'm trying to explain things, but sometimes I don't understand it myself, so. So, okay. So let's see now, negate. I think that was another one on the list of yeah, see? It's undefined for negate. So I wonder if the way he's implementing negate is basically as a subtraction? I don't know. I'm literally negating the value here. So how would he be setting half carry in this case? Replaces the operand with its 2's complements. Alright, so let's go see what this other emulator does for negate. Neg A, neg B. Inst neg, okay. So instruction negate. Okay, so he literally does the complement here. And then after that, actually does a... Okay, hold on a second. So he is doing it as an add. Saying, what if we add 0 plus the complement plus 1? Okay, so this is basically the 1's complement plus 1. That's interesting. It's kind of cute, actually. I mean, I guess this is really probably more what the hardware does under the hood. That just seems to be the, yeah, see, essentially 0 minus data. Right. So like if I was to do what is it called? Subtract info, I called it. A, B, carry condition code. So same idea. So let's say 0 minus value, no carry, condition code. Did that do the right thing? Let's see. Oh yeah, I gotta stop my emulators here. Now I understand a lot more where these half carry differences come from. In the end, what Vectrex is doing is it makes sense, right? It's saying, you know, there are certain operations, and I guess all of these 7 that where it says the half carry is undefined, this hardware is probably wired through the addition logic in the hardware. So it ends up setting the half carry, probably, but it's technically undefined in the sense like this operation, it doesn't make sense to care about the half carry. You know what I mean? Like if we negate a value, even though it's 0 minus the value, checking the half carry doesn't make much sense here. So don't bother, even though the hardware probably sets it because it's using the same hardware that's used for adding 2 8-bit values. You know what I mean? So in a way, it's kind of like Vectrex is emulating the hardware more accurately in that sense. Okay, so we got another mismatch. Let's see which one this one is. Oh, so that did not quite work out. I think my half carry is being set to the opposite value. See, because I'm doing the same kind of thing. Subtraction is basically A plus the complement of B plus 1. So why would that be different for me? Zero. Okay, so we got the value here. Should be 0 minus the value. We have no carry to push through. We're updating CC here. And then we do the add impl. Comes up here. Test carry. Same test. Oh, actually he's doing it as an addition. 0 minus that should be the same thing. I'm also doing it as an addition. Yeah. This is very similar to what I'm doing here. Basically what I'm saying is I have two values that if we were to add them, I want to know if we would be carrying out the bit in position 3 into 4, because that's basically what a half carry means. So like if we come here, let's say we let's clear this here. So like a half carry would occur, let's say, if we were to add two values like this, because then the result would be that this bit would end up over here. Or anyways, this plus 1, let's say. No. Say here, this plus 1 would cause a bit to come up here. You know, plus 1. Can I do that here? Oh no, okay, I guess I can't do math there. But there. So if we added 1, and this would cause a half carry. So what I do is, to know if a half carry would result, I take the two values and I say, well, if A has any bit set in the bottom nibble and B has any bit set in the bottom nibble, right? If this is true, and what am I saying here? And adding them, okay, sorry, so I mask out the bottom nibble of both and I add them. And if the result of adding them has any bit set in the top nibble, then that would mean a half carry occurred. Does that even make sense? I suppose it does, right? Yeah, that makes sense. So like, yeah, basically, so basically what I'm doing here is I'm saying for adding two values, that's where I compute the half carry based on the addition of those two. I don't do it in the 16-bit case, but that doesn't really concern us. And subtract is written in terms of add by saying add A to the complement of B, the 1's complement of B, plus 1, and potentially plus a carry for certain instructions that check with carry, like means we want to do this operation, but we want to take the carry into account. So there are a few like that. For example, here, subtract with carry. Here we pass in the carry's value. So that gets added to the, so you know, it'll be like the plus the complement plus 1 plus the carry value. Now in my case, we were able to, so we're trying to implement negate here as a subtraction. We're saying 0 minus the value, which really should be the same thing, right? Does that make sense? Yeah. So let's see, what were our values? We're trying to negate A. So A has 80. So like basically what we're doing is we're saying 0 minus 80. Yeah, you know, I guess I'm not really doing this computation correctly. This is actually a case in point. I was just thinking about this. There was something weird. There's something weird in my how I calculate the half carry. And it's the fact that I'm checking all the top bits and not just specifically bit 4. And I think that's where I'm going wrong here. Hey, what's up, Pyro? Yeah, so I think now that I think about it, I think to make sure that a carry has occurred when we add the two values, I really need to only be checking if this bit got set in the result. So I think that makes sense. So not hex F0, but hex like 10 basically, right? Just one bit. So let's see if that gives me something more accurate. Can't sleep? Well, thanks for joining. Hopefully I'll keep you entertained. Let's see here, server, client. Oh, got another mismatch. No, that didn't seem to do the trick. Yeah, I'm fixing bugs in my CPU. I don't even know if I'm really fixing bugs, because right now I'm like trying to fix the half carry computation for instructions for which technically it doesn't matter, for which it's undefined. But I looked a little bit at Vectrex, and I think what it does makes more sense. So I kind of like I think I should try to do something similar here. So we have 80 in A. Okay, I'm just thinking about this for 1 second. So we've got 80, right? Which is basically... Now, to negate this means to say, 0 minus 80, which is basically 0 plus the complement of this plus 1. So now I'm thinking, okay, so would this cause a half carry to be set? And I mean, I suppose it would, wouldn't it? So, okay, and then basically there's the answer here. Right. So the complement is 7f plus 1. So yeah, so the answer is back to the same value we had before. So like, if I'm looking actually at this bit here, there should be no half carry here. Yeah, so half carry is I was explaining this earlier. So half carry is basically, you know how like carry bit means when you add, say, two 8-bit numbers as unsigned values, a carry occurs if, like, the top, let's say bit 7 of both are 1. That causes, when you add the two, a 1 to result, which would carry out. So a half carry is basically, on this CPU, means we take bit 3 of the two values that we're adding, and we want to see if adding bit 3 caused a carry into 4. That's usually what, Now it's interesting, Vectrex, the way they treat it actually is kind of smart. I have special code to check specifically for that case, whereas Vectrex is saying, well, given two values and a result, it looks for if it carried. And I have that, but for half carry, I'm checking specifically bit 3. Whereas Vectrex will shift left by 4 and just kind of go back, kind of fall back onto regular carry bit logic. Yeah, it's a nibble carry, exactly. It's kind of weird, right? But I guess useful, right? If you need to do, if you want to use nibbles to do like counting. I just say weird because I didn't even know that existed. So like, I mean, this is a case where a half carry should not have been set, but for me it did get set. So that just tells me the way I'm no, sorry, it's the opposite way. Vectrex considers that a carry did occur here. Oh man, that's so confusing. So, let me see here. Yeah, I guess a carry would have occurred, right? So maybe what I was doing wasn't completely off. Yeah. So yeah, you're saying maybe because maybe because you carry the bit from bit 0 all the way to bit 7. Yeah, but in the end, what I do is I take this value plus this value, and then I look to what I used to do was just look to see if the result had any bit set in the top. Sorry, no, I took this nibble plus this nibble, you know. So what my logic, and I mean maybe that's flawed. What I do is effectively I mask out, let's say for this value I mask out the bottom nibble, and I say take this and then add it to the bottom nibble of this one. So effectively this, like if we, and I say like look at the result of this here, of this add, right? So that's going to give us basically right? So I mean, based on this, shouldn't it set the half carry? Yeah, let me just make my font just a little bit bigger. So it should have been set for me, but it did not get set. Okay, that's interesting. Let me see if I can understand why. See, this is what I was talking about. I have this calculate the half carry from an add. So I want to add these two 8-bit values. So that's it. I mask off the bottom nibble for A, plus I mask off the bottom nibble for B. And then I take that result and I see if I just made this change here. It's setting this to 1, 0, but I used to have checking all nibble, like top nibble in its entirety, but I think it makes more sense to just check the 1 bit, because we're specifically looking for a carry from here into there, so that should be fine. I mean, in any case, it's not possible to get a bigger number than that, right? Since I'm only adding 2 nibbles here. So whatever. So this should have given me what I expect, which is setting the half carry. So let's see. Yeah, you think that should be fine? So do I. So let me see here. A and B. Oh, wait a minute. Okay. Okay, I know what's happening. It's because what's happening is that I'm calling subtract impl with 0 minus the value, which is, you know, theoretically correct. But then what happens here is I'm saying A plus the complement of B plus 1, where this is fed into the carry register. But when I compute the half carry, I wonder if that's correct. When I compute the half carry, I don't take this extra 1 into account. I'm only looking at A and B. And you know, I think the reason why this always worked for me is because subtraction doesn't compute half carries, so it doesn't matter for subtraction. So then I need to go check in the addition case. And I guess actually in all the addition cases, we never pass in a 1. So again, it doesn't matter. That's why. No, we do have an add with carry here. So then there's a question there. Add with carry. Yeah, see, like in the case of add with carry, we don't want to take the carry's value into account, right? We just want to see whether there was a carry when adding, let's say, the register here with whatever we read from memory. Is that correct? Maybe that's not correct. Let me check something. ADC, let's say. Yeah, I actually think I think that's wrong. I think I am supposed to consider the carry when I do this add. Yeah. Yeah, something like that, exactly. Yeah, I think so. I mean, technically at this point I can just like do plus carry on any one of these and it would do the same, would have the same effect, right? Oh, you're adding the carry outside, but I think it ends up being the same thing. Or does it? Well, no, maybe not. Yeah, maybe I could pass in the carry and add it like that. Yeah. Let's see. Pyro, let's see. Let's see if that's the answer. By the way, I don't know if I've mentioned this before, but dealing with add, subtract, add with carry, and subtract with carry, this was probably my least favorite part of implementing the CPU. It's tricky. I mean, I find it tricky getting that part right. What do you know? You've only implemented the chip 8. Does chip 8 deal with carry bits? I haven't done the chip 8 emulate, I haven't emulated chip 8 yet, so I don't know the details of that one. But does it deal with carry? This is pretty good, right? Let's see if we can play a little bit here. They had the Game Boy emulator. You want to do a Game Boy emulator? You know, a friend of mine, he actually is sometimes on stream here. He implemented a Game Boy emulator, and it's true there are a lot of instructions, but if I recall, he told me that, you know, if you pay really close attention to the way the instructions are encoded, there are some pretty clever ways you can go about you can go about kind of breaking up the way you handle instructions into these sets, you know, and like in the end, this this combinatorial explosion can be broken down into, like, you know, the log n parts of handling those instructions, if that makes sense. Because it is really just a combination, right? It's like a lot of those instructions are just combinations of the basic parts of what it can do in that CPU. You know what I mean? And I think it's a variation on the Z80. So yeah, like if you like read through the instructions for the Game Boy, for the CPU, and look specifically at how the instructions are encoded bitwise, I think you'll notice the patterns in there, you know, and you could figure out like how in hardware it must be implementing those, you know, those instructions by looking at which bits are set. Like I think it's one of those that's a fairly stable, like I don't know what the right word is, but like a kind of consistent. There's like a consistency within the instruction encoding, which by the way is not the case for the Vectrex CPU. So I tried to look for patterns like that to see if I could like break it down, but it's kind of like a Frankenstein CPU in the Vectrex, the 6809. Yeah, that's right. This gamer is mentioning about the undocumented instructions. Yeah, I think some of those instructions may even be used. So are you saying this from experience, Lisp Gamer? Have you implemented one or looked at an implementation of the Z80? So this is pretty cool. We managed to play this game and not get any desyncs. So yeah, I'm pretty confident that having to add the carry in there was the right thing. So thanks for the help on that, Pyro. The complexity is in the prefix bytes. You suck at graphics. So, little secret, Pyro, I suck at graphics too. Like seriously, you know, when I see, you know, before I started this project, I actually had done nearly 0 shaders. I like, you know, would read about it and I'd like look at code a bit and all that, but I had like no real experience writing any shaders. I wrote a NES emulator and I used SDL2 as well, but I used like actual, you know, pixel buffers. I forget what they called them. Whatever they call it. Surface? I don't know. And yeah, I think it's called an SDL surface. And I just, you know, was writing pixels. And that works for the NES, but for the Vectrex, I wanted to be able to do proper vector drawing. So I started with OpenGL immediate mode, which is like about as basic as it gets. So I knew OpenGL immediate mode, but I didn't know any like, you know, non-fixed pipeline shader stuff. And I used this project as my way to learn. So yeah. You hate how complicated graphics library? Yeah, I get that. I get that. I mean, do you know, like, at least, you know, like basic immediate mode OpenGL? Is that something you know? Or actually, in the case of the Game Boy, you really don't need to know that, right? Thanks, Lisp Gamer. Thanks for hanging out. Right, so Pyro, if you know SDL, and you know, for a Game Boy emulator, you'll just be using an SDL surface, writing, you know, 4 shades of values, or I guess 5 possible values in there, you know? Or is it 4? 4 shades, yeah. Like nothing and 3 values. Yeah, so okay, so you've never gone to OpenGL, but you don't really need to know OpenGL or Direct3D or any of that stuff for a Game Boy emulator. It's really just SDL surface, and you just write pixel values, you know? So I think that would probably not be the hardest part in terms of implementing a Game Boy emulator. You get some like linear buffer of RGB values, and you just, you know, write RGB values in there. You should just like mess with it, you know, like download SDL and just get a basic project and just create a screen, you know, a fake Game Boy screen, and see if you can like write the 4 different shades of green and see what it looks like, you know? I think just having like something visual you've done, even if you're just messing around and just writing pixels, or like maybe with your mouse, you know, like figure out where you've clicked and draw in a low-res Game Boy looking screen, that could like give you the little kick you need, you know, to kind of get into it. So I just wanted to see here, like when we were searching before, there were other, we go to negate A, let's say again. I was looking for this, h equals to undefined, and we had found 7, right, of these? So I want to see if now ASR. Yeah, I think it would be fun. So arithmetic shift left is basically a division by 2. Yeah, so I wonder how... ASR. So I wonder how did the other emulator do something for ASR? Cannot be faked as an add or subtract. So in this case, he does not set the half carry. So that matches what I do. So that's cool. So compare we did. Okay, let me just start with 1. So number 1 is ASL. So we took care of ASL. Number 2 is ASR. We just saw we can't do it for ASR. Compares. Whoops. ASL, ASR, compare. LSL. I think LSL is just ASL, isn't it? That's why it's the same. Yeah, it's the same thing. Negate, we just took care of. Subtract with carry. So this one now, so I guess my subtract with carry would now end up setting it. Yeah. And then subtract as well. So yeah, looks like now I'm setting the half carry exactly the way Vectrex would. This is pretty good. So that means What that really means is that suddenly I do not need this parameter because we're just going to always update it. Forget conditionally updating a half carry. So we'll just get rid of this. Yeah, so, okay, so Pyro, basically, in my emulator, whenever it said it was undefined, I didn't compute it, right? So, you know, I totally agree. However, when I would compare my emulator to the Vectrex one, it was always on the half carry that we would differ. Like, I wouldn't compute it and then it would. And what I realized is, so that obviously that messes up my, like, you know, desync detection to try to find differences. But then I looked a little bit at its code. I'm trying to understand why, you know, and it kind of makes sense. You know, this is what I've been doing now is, if you think about it hardware-wise, some of these instructions where it says it's undefined are actually written in terms of an addition. And so hardware-wise, it's got to be going through the same, you know, same hardware circuitry to compute, let's say, the negate, which is really 0 minus the value. The compare is also going to be going through to a subtraction. So all of these are going through the same circuitry, and the subtraction can be implemented in terms of addition, right, with a carry and all that. And so ultimately, half carry would be computed in these cases. It just, like, it's just undefined in the sense of it doesn't make any logical sense to read a half carry in any of these cases. Exactly. Exactly what you just said. It actually computes it, but the data sheet says not to pay attention to the bit. Yeah. So I think that Vectrex actually is doing the right thing in terms of emulating hardware more accurately than what I'm doing, which is, like, you know, saying, oh, there's no need to compute it. And I mean, I could totally get away with what I had. It's not wrong, but it makes my CPU different from Vectrex, and it's just making it annoying for me to find bugs. So may as well do it, like, quote unquote correctly in terms of hardware, even if it's not important in terms of emulation, if that makes sense. Okay, just want to put some comments in here. So negate is the same as 0 minus value. Okay, so let me see now what my diffs look like. So I just, like, made a bunch of changes in the CPU code, so let's see if we can get that committed. Oh yeah, I gotta remove my optimized crap. Okay, so carefully. Alright, so I've changed this to calc half carry from add. Remove this enum and I remove that parameter. Okay, so let's stage the stuff here. The rest that's in here is the Vectrex CPU stuff, so I don't want to put that in there. CPU helpers, yes, we fixed. Alright, that's important. Yeah, this is not actually related to this specific change, so I'm gonna hold off on that one. But here on the debugger, I could actually remove this hack now, which is nice. Removing hacks makes me happy. Post-op write trace info, push back front, okay, and then current trace info. All right. And we have the compute running hash and the number of instructions executed this frame. What is this weird song? Alright, so what I'm going to say here, re-implement certain instructions in terms of add subtract. So that half carry gets computed even when undefined. So you're asking, so how do you compare your emulator with the hardware? That's something I haven't yet seen on YouTube. So I don't. I have the hardware, but there isn't any like. You know, there isn't like, I know like you've been obviously watching Ferris and he's got like the serial port on the Virtual Boy that allows him to do that really cool stuff he's doing to like compare, you know, how his emulator behaves versus what the hardware does. I'd have to like literally open up the Vectrex and wire stuff to it. And even then there's no like protocol, there's no serial protocol or anything like that. There are people though doing all kinds of crazy stuff with the Vectrex, so you know possibly I could maybe get a cart that I think like through the cart you can read pretty much all of the address bus, so there may be some ways to get what's going on the address bus, but like actually getting the state of the CPU would be a bit more challenging, but not impossible, you know. So I'm pretty much doing what I did for the NES emulator, like comparing myself to what is deemed the most accurate emulators. So it's definitely not, it's not. I don't think I'm gonna have the kind of hardware fidelity that Ferris is going for with his emulator, but yeah, I don't know if I care that much, to be honest, for Vectrexy, or maybe I just don't care yet, right? Like right now I just want to get most games working. I'm not even there. Maybe once I've got a whole bunch of stuff working and it's it seems pretty good, but it's like still a couple of little things that are not quite accurate, when looking at hardware, maybe at that point I'd want to look really closely at what's happening at the hardware level and compare it. You know what I mean? And to be fair, I think that's where Ferris is at. He's implemented it. It's pretty much supports pretty much all games. Like his compatibility is 100%, and he has like very minor bugs left, very minor glitches. And so he's at the point where it's like he wants it to be as close to the hardware as possible so that everything is really 100% with no glitches. So maybe I'll get there, you know? But I'm still a bit of a ways off from there. Like just looking over the compatibility list I have here, like there's a whole bunch of games that are just not even, you know. And of course now I fixed like a bunch of CPU instructions since I went through this. I need to kind of go back through it, but I'm doing that by picking games that look like would be good games to test against. So right now I was focusing on Spinball, because I knew for a fact that it worked with Vectrex and not with mine, and it was kind of a good first one to test. So after this, you know, I'll pick another one and we'll see if we get some desyncs. But having implemented the desync detection into my emulator is basically going to help me iron out all these bugs, which is really cool, right? Prior to this, it was more difficult. I would run my emulator. I would like run my emulator and load a ROM and produce this massive trace, and then I'd use the Vectrex CPU and then run the same game and produce a massive trace, and then I'd try to compare these like huge files, you know, and like just trying to line them up in Beyond Compare was super hard, and like timing issues would cause that, like would make it basically impossible for me to line them up. So I thought about it and I was like, what am I gonna do, you know? And I came up with this idea of let's run two instances, and yeah, exactly. So I was like, let me run two instances, one with my CPU and one with another one, like a different host CPU, and let them talk over the network. And after every frame, I will have executed, let's say 50,000 instructions, right? And we keep them in lockstep. So they sync at the beginning and at the end of every frame. One says start frame, the other one says okay, you know, and then at the end the server says I'm waiting for you to finish your frame, and then the client says okay, I'm done my frame. So they keep in lockstep, and also the server sends the delta time and the inputs, so they both, you know, use the same amount of time and the same inputs. So they're basically completely in sync. And also, let's say that those 50,000 instructions that we executed, we hash all the instructions into this 32-bit value. And then I send one to the other one and it just compares them. And usually they're the same, but as soon as the hashes are different, you know, they both, like, you know, they communicate whether or not they should keep going, right? So as soon as the hashes are different, the client says to the server, okay, hash is different, so we gotta stop. And then they both stop and say, okay, instruction hash mismatch, something is different in the last n instructions, and n being how many instructions were executed this frame that just passed. So that's what you saw like in my output here. When you see here, like here, you see instruction hash mismatch in last 42,016 instructions. And usually it's the same on both. It's not always the same on both. And then what I do is I'm broken into my debugger exactly after that occurs, and I output a trace log of the last 42,016 instructions on both, and then I do a compare. And now I'm really comparing just one frame's worth of instructions, and they both pretty much start exactly the same instructions. So that's what you saw here in Beyond Compare. See at the top here, this is the top of this frame for both of them. It executed all of these instructions, and the diff showed up here. And then I can just look here, and this is my trace log, right? So I just look at the diff, and the diff is the half carry. Oh, thanks, man. Yeah, I don't know where I got this idea from. I think there's like a few different influences. At first, I started with, I knew, I kind of felt this wasn't gonna work, but I was like really naive, and I'm like, how about after every instruction, I just send the instruction from one side to the other and compare them. And then of course my emulator ran at like, you know, negative frames per second. It was extremely slow. So I was like, okay, that's not gonna work. And so then I'm like, I guess I got to do this once per frame. And I was like, but how do I, I can't send every instruction. And I know that, I've worked on a few games that do lockstep for, let's say, like real-time strategy games. So RTS is kind of work this way where they need, so RTS games, there's so much going on that unlike a lot of multiplayer games, you don't want to be sending every single unit's position and direction and all that, because that would just be an insane amount of data. Like when you think about, StarCraft, right? And you have thousands of units that are fighting against each other. You can't really be syncing thousands of units worth of data over the network. So what you do instead is you make sure that your game is, what's the word I'm looking for again? That the game will run exactly the same way on all machines. I'm blanking here. There's a word for that when you can be guaranteed that the game runs exactly the same on different machines. But anyway, and all you transfer is inputs, right? So you just transfer inputs and you know that the game will run the same way. Now the thing is, if they don't run exactly the same way, you'll get drift. They'll desync, right? And so what I've seen in one of the engines I worked on that was an RTS game, is that, like, for development purposes, what they do is they hash different pieces of data, and then they send the hash across and they make sure that the hashes are in sync, and that's how they do their desync detection. And like the more things you hash, the more chance you'll find desyncs early, So they'll hash things like the positions of all their units. So I guess I was sort of influenced by that, even though like I actually didn't spend any time in that code in those engines. I just kind of heard about it and sort of half understood. Oh yeah, that makes sense, But yeah, so the only time I used sockets was a ping command from PS Vita, but I've come to realize that sockets can do so much more. Yeah, and actually I hadn't written any like network socket code since like university, which was quite a while ago. We're like talking like 2000. So it was kind of a chance for me to get back into that as well, That's what's really been cool about this project, is like, it's kind of forced me to explore different things. So explore shaders, re-explore network code. It's fun. It's really, that's the point of doing these personal projects, right? Okay, so I just wanted to re-implement certain instructions in terms of add subtract so that half carry gets computed even when undefined. And I'll just say, although, and I want to say which instructions these are.
I have a question. Why is it Dungeon Mans? I mean, that's kind of a weird word, right?
You pose an interesting question.
Who are you, guy? Where'd you come from?
It's one that must be answered.
Instructions.
You could just tell me.
Affected. ASL. What was the other ones?
Bon Jovi here? Are you playing drums? Who's playing drums?
ASL. ASR, of course. Compare. LSL is the same thing as ASL. Negate. Subtract, I already had that, and subtract. Okay, so these are the ones that really, although not necessary, this is probably how the actual hardware works, and is how the Vectrex CPU implements it. So comparing against it is easier when half carry computation matches. So commit that. And I wanted to commit the CPU helpers here. So this here fix. Fix indexed mode instructions. Not adding, how can I say this? Fix index mode instructions, failing to add signed offset because I'll say signed negative offset because value would not be correctly sign extended when I'll just say sign extended. Just as a FYI about chip 8, chip 8 has 16 8-bit data registers named V0 to VF. The VF register doubles as a flag for some instructions, thus it should be avoided. In addition operation, VF is not, no, VF is for, in addition operation, VF is for carry flag. Okay, you mean, oh, I see. You're saying when you add, the addition operation sets VF, sets like the carry flag in VF. So it has a carry flag but no half carry. Okay, that's cool. And so there are there like add with carry and subtract with carry on the chip 8? Because those are the annoying ones to have to deal with. And like how when you're doing subtraction, carry is actually set when the subtraction causes a borrow. So it's like it's got like the negative interpretation. It's even though it's a carry bit, but it's actually a borrow bit in the case of subtraction. Oh, I wanted to put CPU here. All right. That's pretty good. So I got everything committed. Let me just push this up. See, we fixed a whole bunch of stuff. We fixed ink, rotate left, rotate right. We fixed indexed mode. We've now are computing half carries for, even though that's not necessary, we're doing it anyway. And things are looking pretty good. So I'm gonna end my stream soon, but I just want to change this here. And I guess I can say great here. I'd say this one looks like it's working quite well. So I can remove that. How do I format this again? Like that, okay. I don't know if you saw this there. I'm using VS Code and I'm using this plugin for Markdown. This extension in here. What's it called? Markdown Lint? No, not Markdown. Markdown all-in-one here. And what's cool about it is that like I have a markdown table in here, and markdown tables are just obnoxious to like keep aligned and stuff. But when you're using this thing, I can just go Shift-Alt-F to format, and I don't know if you saw it, like it moves things correctly. And like if you make, let's say, this line wider, it'll just fix the entire table to match, you know? So if you're looking to do some Markdown, I can highly recommend VS Code with the Markdown. It's called the Markdown all-in-one extension. Yeah, it's pretty sweet. I kind of like avoid doing tables in Markdown. I was always avoiding them before this because it's just so annoying to have to like line things up. And I mean, you don't have to, right? Like Markdown renderers don't care. But since the point, one of the points of Markdown is being able to read this file as a text file, not doing the formatting is just kind of shitty, right? So So I feel like just finding like the next ROM I'm going to work on and just seeing what happens when we run it. Okay, let's take clean sweep here because this one has an invalid cartridge read. And I have a feeling that the things we fixed specifically related to the signed offset for the addressing mode, the indexed addressing thing that we just fixed, should fix a lot of these. So like, I'm just curious. Let's just try a clean sweep here. And I just want to run it, you know, if it doesn't work, we'll stop there. I do have a few missing ops. You're looking at my compat list. Yeah, I have a few of these missing ops here. Like SWI, CWAI. I think these are all related to interrupts, and I just didn't feel like implementing them yet, because actually they're not used that often. But yeah, I'm gonna totally have to do it. It's because I started reading about these instructions and I'm like, but yeah, I need to implement them. But I did implement the entire CPU. Okay, so let's see here. I just need to show this in the background. Oh, look at that. So we're still getting the read from unmapped range for clean sweep. But is it the same thing? Yeah, it is. Okay. Well, I mean, we have different addresses, but I do have invalid stuff going on in here. So it'll be interesting. I actually, you know what? A quick test. Let's see if the Vectrex CPU is able to run this. So this is the Vectrex one, yeah. Yeah, ouch indeed. Okay, so this happens with Vectrex. So this is not a CPU bug. Because I mean, if it's failing Vectrex, it's something else going on there. Actually, I want to see this one here. I was wondering about there's like input doesn't work here. I can't drive straight on pole position, and I was wondering if that was related to some of the fixes with like arithmetic shift left or shift right. So let's see. Pole position. I want this game to work because actually pole position is a really cool game for the Vectrex. It's a racing game, but I can't quite play it because my car doesn't go straight; it just keeps going left and right. So it may be fixed now, or yeah. See, I have these read and unmapped range problems. Yeah, so something's definitely up here. Let's just see. 3, 2, 1. No. Okay, still, see, I'm still pointing always to the left. So that's not working. Oh, thanks, man. Thank you very much. I worked a long time on the glow effect. If you go back and watch some of my streams where I'm implementing graphic stuff, there's like a whole chunk of videos of me just working on the glow effect and you know, kind of rewriting my shader code to work with that. That was really fun stuff. It's like in my GL render code here. You can see like the different shaders I have, and like in there I've got a glow fragment shader here, and I have a glow pass, which basically is just doing a Gaussian blur in 2 directions. So that's why you see 2 different calls to glow in direction here. So yeah, I know my videos are long, right? I know it's a lot. I don't really. But one thing I've thought about that could be interesting is, I know like what's called Handmade Hero. I know people like, obviously he's super popular, KC Muratori, and people watch that, and they like there are people who go and index the videos and like say, if you want to watch things on this, you can just watch these sections of his videos where he covers that. And I thought, maybe at some point I'll go back over some of my videos and try to like at least break them up into sections. Like this is where I worked on CPU stuff, and this is where I worked on graphic stuff, and input here, sound, debugger stuff. Because like, I don't usually work on just one thing, but I'll do like one thing for a little while, switch to something else, switch. So, and usually those last a few videos. So that might be useful. I don't know. I've got 51 videos to go through right now, so maybe it's still tractable at this point. So yeah, I think I'm looking at the time. I think I'm gonna cut the stream now. So Pyro, thanks for hanging out. Anybody else who's watching, thank you. And yeah, should be back next week on Monday. So yeah, I'll see you around. Thanks a lot.